Understanding how 4D spacetime really works is difficult because we don't actually see space itself. So we're going to have to examine Newton's laws of motion in order to infer what space is doing with matter. Newton's first law of motion: an object remains at rest or in motion at a constant speed in a straight line unless it's acted upon by a force. This tells us that spacetime preserves an object's momentum through spacetime. Newton's second law of motion: at any instance of time, the net force on an object is equal to the object's acceleration multiplied by its mass, or equivalently, the rate of which the object's momentum is changed with time. This tells us that spacetime resists change in the object's motion in accordance with the object's mass. Newton's third law of motion: if two objects exert force on each other, these forces have the same magnitude but in opposite directions. This tells us that spacetime does not impede interactions of matter with other matter. It is a neutral stage for events and serves as an objective arbitrator of interaction. On this foundation, we can include special relativity and the understanding of motion through a fourth temporal dimension. The first law of 4D motion: spacetime preserves an object's momentum at a constant ratio of motion in the spatial dimensions and temporal dimension at a constant rate known as the speed of causality. The second law of 4D motion: spacetime resists change in momentum through all four dimensions, and in order to change the object's momentum, it requires energy in accordance with the object's mass. Third law of 4D motion: spacetime is an objective, neutral arbitrator of motion, and in collisions between objects, the magnitude is shared equally. Fourth law of 4D motion: spacetime is the ultimate framework for motion, and your momentum is always in the opposite direction of your local frame of reference, which is space. When you understand 4D spacetime, then you can see the relationship between space's relative direction of motion and matter's momentum. You will see that the momentum is always in the opposite direction to your relative motion to your spatial frame of reference. This shows us how the outward acceleration of space causes you to accelerate towards the Earth. This happens because space imparts momentum to you in the opposite direction of its motion. This is why all objects accelerate towards the Earth at 9.8 meters per second squared regardless of its mass. When Albert Einstein imagined gravity, he equated the gravitational field to be accelerated frame of reference as if the Earth were accelerating upwards towards us, because it seems like that, but if you were to imagine it, you would see that it just cannot be. Because if the Earth were rushing upward towards us, not only would the people on the opposite side of the Earth fall off, but time dilation wouldn't work as it does. Eventually, the continuous acceleration would mean increasing time dilation, and then eventually it would reach the speed of light, and then there would be no more acceleration. This is why Albert invented curvature as a MacGuffin, to explain away the problem. And Albert never exactly explained how matter curves space, or exactly how this causes time dilation, because you cannot. However, if we imagine a spaceship accelerating at 9.8 meters per second for its journey to a distant planet, it would have to turn around at the halfway point to start decelerating against its momentum so it can slow down and avoid crashing into its destination. This is the way to think about our orientation relative to our spatial frame of reference in a gravitational field. Because the Earth is resisting our momentum that has been imparted to us from our spatial frame of reference due to its acceleration outwards from the Earth. This is how we can both accelerate towards the Earth and yet not have our time dilation ever increasing. It's the combination of the space's acceleration of us and the Earth decelerating us to give us the feel of gravitational force. The Earth is resisting our momentum that has been imparted to us by our spatial frame of reference due to its acceleration outwards from the Earth. This is how we can both be accelerating towards the Earth and yet not have our time dilation ever increasing. It's the combination of spaces accelerating us and the Earth decelerating us that gives us the feeling of a gravitational force when we press against the Earth. And is because we are moving relative to our spatial frame of reference that we see time dilation in a gravitational field. Since the flow of the space outwards from it and follows the inverse square cube law, we also get the gradient fall off of time dilation in a gravitational field. Because if we understand that dark energy is the source of the gravitational force in 4D space, it is expanding from everywhere, and we can see that, like in fluid dynamics, matter would accelerate space within matter outwards from the Earth, resulting in a gravitational effect and turbulence in space in between these gravitational effects. This is what I believe is the cause of the dark matter effect. Since space itself is a medium for gravitation and we do not have any matter to account for this effect, I think it's safe to say that it's the turbulence within space causing the dark matter effect we observe.